Hello guys, welcome back to Unit 2 for the IPC Flipped Classroom. Once again, I'm Mr. Hawkins and I'm your teacher. Today we're starting our new unit, and this unit deals with physical and chemical properties of matter. We're going to get into states of matter today. The next VOD we're going to watch will deal with properties of matter, physical and chemical. The final VOD that we'll have for this session will be density. So today's is kind of a little bit long, but it's very interesting. So what is matter? Okay, so we talked about mass last unit, and mass told us how much matter something had in it, right? And mass is essentially the stuff that fills up everything around us. Okay, matter consists of atoms, and that's why they always say don't trust atoms. They make up everything, so that's kind of funny. But yeah, what is matter? Matter is the stuff that fills everything around us. Matter is anything that has mass and takes up space, okay? This is the typical textbook definition that you see of matter. It is always like this. Once again, two key factors there. It has mass and it takes up space. Now, what is space? Space can be anything to the size of this cup. It can be the inside of this cup. It can be the air around us, okay? So in this office right now, we've got matter floating around in the air. And it's also composed of different types of atoms, okay? Like I said, atoms make up everything, all right? So you can't trust them. So you probably are well aware of the different states of matter. You may not be alert on the fourth one. We're actually going to do an exploration about these in class, so it's kind of interesting stuff. First of all, we have solids, followed by liquids, gases, and then plasma. Plasma is interesting stuff, mostly because it's ionized gases, okay? And we'll talk a lot more about ions whenever we get into ionic and covalent bonding next unit. But for right now, just understand that plasma is nothing more than really high energy gas that gets these atoms moving around so much so that they lose all their electrons, and it's just a giant charged sea floating around, okay? Also, I guess it's important to note that liquids and gases are fluids, which means that they flow, all right? Fluids flow. Solids are strictly solid. So solid matter exists with a definite volume and a definite shape, okay? So that means that this cup specifically takes up this much space. It has a definite volume and a definite shape. Constituent atoms, the atoms inside this, are tightly packed together, and they're all in some kind of alignment. All right, whether it be very straight or if it be crooked, okay? That all depends on what type of bonding is going on in there and what type of atoms are present in it. But for as much as we need to know, just understand that solids have a definite volume and a definite shape. They can change to liquids. We also have phase changes that can occur, and these are physical change, which we'll talk a little bit more about in a couple of units. But solids can change to liquids by melting, and then they can also go straight from the liquid or the solid phase to the gas phase by a process known as sublimation. And that happens a lot in dry ice. We're going to do an experiment with that in class. Warning. Much like the structure of the aliens in this video going on behind me right now, solids actually kind of look like this. I know this is actually a clip from the video game Space Invaders, where these aliens up at the top are kind of going to attack the poor humans down at the bottom, okay? What's going on here, okay? You have this very tight arrangement of the aliens, right? If they were all spread out, they wouldn't necessarily be a solid, right? So assume that this was our solid. We have all these really tightly packed aliens that don't have much room to wiggle around. They can only move in this structure, and they all move at the same pace, right? They're not all split up and moving at individual speeds. Not yet, anyway. When you get to the higher levels, then you get the crazy ones that do their own thing, right? But for right now, they're all really tightly wound and really tightly stuck together, trying to attack the same thing. So essentially, solids are kind of like this. Solids act as one. The atoms are very tightly arranged, and they're moving as one, okay? They take up a specific volume, just like the cup. We now take you back to your regularly scheduled VOD. So then we move on to liquids. Liquids would be the stuff that I fill up this cup with, right? Water. It has a definite volume, but it does not have a definite shape. So if I put a cup full of water in here, I essentially have placed in the volume that this cup will allow, okay? It does not have a definite shape. If I, for some reason, get really nervous and spill this water all out all over the place, it's going to move around and flow, right? Fluids flow, fluids flow. It will flow to cover some area of space. They will take the shape of whatever their container are, okay? The water will look like this cup, but if I pour it into this cup, it will essentially be round, okay? It takes whatever shape of the container that it has. It can also change to a solid by freezing. This happens with ice, right? Anybody ever made the cool little popsicles with Kool-Aid? If you put them in the ice trays, right? You put some toothpicks in them and you put them in the freezer, you have little ice cube tray shaped popsicles, right? Same thing. That's freezing. It can also change to gas by evaporation, which happens when you boil water to make pasta or something like that. Finally, we have gases. Gases have no definite volume and no definite shape. So all around me right now, I'm sitting in the midst of gases, and you're like, ooh, you're disgusting, Mr. Hawkins. Well, no, hold it, okay. Gases have no definite volume and no definite shape. Whatever the gas is, all these particles bounce around and fill the shape of this container. So all of the oxygen, all of the nitrogen, and other things in our air have all bounced around and managed to fill the shape of this room or atmosphere or anything like that, okay? If you take some type of gas and put it in a closed container, you can watch it fill the shape of its container eventually by a process known as diffusion. Hang on to that little nugget. Okay, so gases can change to solid by deposition, which is basically the opposite of sublimation. When in sublimation, the solid went straight to gas. In deposition, the gas goes straight to solid. But most of the time, gases change to liquid by a process known as condensation, all right? And that's what makes our rain clouds up above us. All right, guys, if you have any questions or anything like that, please come in for activity period or write them down and ask me tomorrow during our Q&A, okay? If you guys have any more questions, please do that. Otherwise, have a great evening. Thank you guys for logging on.